What are capillary tubes? These are small capillary tubes. You can see them. See how thin they are. They are very thin tubes and are made up of glass, and some of them are also made up of plastics, which is also called rigid material. Now these are helpful in experiments which are small scale procedures are done. They mostly have diameters 1 millimeter, 0.6 mm and 0.4 mm. These are of many types and are used to find melting points of different compounds also, and they are used for collecting blood samples by capillary action, right? So these have mostly edges that are rectangular in shape. That is, the edges are rectangular in shape. Some of them are sealed from one end, but now these are both are open from both the ends, so we need to seal them. Now I will tell you how to seal them. And when they are sealed from one end, it becomes more easier to fill anything into it easily. So, and it is also used for recording melting point, and if not sealed, can be sealed on flame. These are also used in experiments involving capillary action on different solvents, by solvents to rise up by a capillary action method, right? These are also used to collect blood samples from the finger, right? By simply pricking the finger. I will explain you how you can do that. Now you can simply seal it as both the ends are open. So we need to, for filling in something, we need to seal it from one end. So you can simply roll it over the flame. If suppose this is your Bunsen burner, how you are simply going to roll it. See, I'm rolling it over this flame, and it's good if you just select the blue flame. But let's see what happens when I roll it in the flame. So there we go. Yes, it's almost closed. You can see it here. It's almost closed, right? Near the camera, if I show you, see its edge, it's almost closed. Still, for confirmation, little bit more rolling on the flame, so that you will simply have no excuse that it's not closed from that end. Yes, now it is closed from that end. You can see it is sealed, perfectly sealed. So now it's ready to fill any compound into it for melting point determination. Sometimes when they are not sealed, you can seal it like this, just rolling it over the flame like this. And pulling it. You see? There it goes. You can see now we have made two capillary tubes from the single one. Right? Now it's very hot from here, but we can simply cut it when it gets harder. This is glass, so you can see the pointed ends, they are closed. Now you have two capillary tubes. From one we can make two capillary tubes, but you need to be very careful when you are heating it over the flame, because the lower ends are very hot. So you need to wait till they becomes, so you can scratch it with a knife and they will become regular in size. They will be of same size, so you have now two capillaries, and this way you can break the two capillaries and they are now sealed from both the ends. In recording the melting point, you need to fill your capillary tube, right? You need to fill your capillary tube with a compound. So let's fill it like this. Tap it, fill it, tap it, fill it, tap it. And do it like that. You have to repeat it again and again. So So you need to fill it like this. Just take few granules and fill it. Take few granules and tap it, and now you will see. You can see that there is a little bit of the compound inside filled in it. Now, as I'm not in any lab, so I just fill sodium chloride into it, right? So you can see this is the same capillary which I have broken into 2 pieces. So you can simply see that yes, it's filled. Now it's ready to record the melting point of sodium chloride. That is the salt, right? So this is how you can seal. You can break the 2 capillaries and then you can seal them from the lower end. From the lower end, how you can seal it if they are not sealed. Whether most of the days nowadays, modern times, you know, the capillaries are all available sealed from one end, but still if you don't get the sealed one, you can, this is the way how you can seal it easily. And then you can crack it down from some razor, and this thing will be removed, and this is it, how you can fill the compound. And now this is ready to be tied down with the thermometer to record the melting point of any compound. As I've mentioned that these are very thin tubes, right? These are very thin tubes. You can see here it's a very thin tubes and are made up of glass, and they are also rigid material. These are very useful in experiments where, you know, small scale experiments are done. They are used, and they mostly have diameter 1 millimeter to 0.6 millimeter, and they can be used to collect blood samples also. They can be used from the finger you can collect blood sample from it, and you can record the time of blood clotting, for how much time it takes blood takes to clot, right? And by the capillary action, the blood just goes inside it. I will just show you how it goes on. And as I've just shown you in my experiment, that how you can break it if they are not sealed. See, these are not sealed. These ones are not sealed, and from both, and I've sealed them, and I also explained you how to break them, how to heat them over flame, and then from the middle you can simply, you need to pull them. You need to pull them, right? And then you will break it from the middle, and in this sense you will be having 2 capillaries from one. If you don't need a long one, because the long ones are not needed here for this type of determination, but for blood clotting samples, to collect blood clotting experiments, you need longer ones. Otherwise you just don't need the longer ones. So let's see how we do the next experiment. For recording, for collecting a blood sample, right, you need to prick your finger, right? So let me prick the finger. Yes. Now just see that it should have enough blood so that you can fill it in your capillary. To see how it goes inside. Again, you need to do this. You see how it goes in. In this sense, you can fill your capillary, and you just see, but there shouldn't be any bubbles in it. There are bubbles, as I did it in a fast way, so don't do it like that. But just see, this is the way you can collect your blood sample for recording, for doing your experiment of calculating the blood coagulation, that how much time it takes to clot a blood sample, right? So I will leave it here for 30 minutes or for 10 to 5 minutes or maybe 30 minutes. It will I will break it, and I can show you how much time it took to clot, right? So in this way these are used.